Hello and thanks for watching. I wanted to do a quick video on this project before it gets too far along. What I'd like to do is do a full series on putting it together and assembling it, the machine work that gets done to it, and so on and so forth. What do we have here is a 440 Chrysler Big Block. This engine is going to get stroked out to a 505 cubic inch. And this is a bare block. We bought it as a bare block, meaning that there was no crankshaft, no rods, no pistons, no timing cover, no heads, no cylinder heads, none of that stuff to go with it. And first order of business when it came here was to strip the cam bearings out of it, take out the core plugs, take out any pipe plugs that were in it. I also pulled the timing cover dowel pins. One of these timing cover dowel pins was so far pushed into the block that I don't think it was going to align anything. So I pulled that one and I pulled the other one. We'll put new ones in. Pulled the cylinder head dowel pins and basically got it stripped down and ready to go. It wasn't in real bad shape when we got it. It wasn't real dirty. But the first order of business was to buy the parts that we needed and get it down to the machine shop once it was stripped. So first thing we did was we bought a set of 2-bolt billet steel main caps. So if you're familiar with billet steel main caps, you probably recognize the name. Maybe you recognize Billet Speedworks, but you've probably heard of the name Program Engineering. So when we first started looking for parts, the first company that I started to look up and use again, which is I've used them in the past, was Program Engineering. It's my understanding that Program Engineering is no longer producing caps, but a longtime employee of Program bought the company from the owner. I think he decided to retire, and he changed the name to Billet Speedworks, and he produces these main caps. So it's a very nice cap. I've had good luck with Program in the past. I don't see any real difference in quality. It looks like pretty much the same cap. The only real difference is when you bought Programs, they were anodized in black. But so what? You know, as long as the cap functions and fits the way it should, which these appear to do the same, I'm not very worried about it. So it went down to the machine shop. First thing they did was they baked it, and when they bake it, what that does is that dries out all of the oil, coolant, grease, carbon, anything in there, and essentially it turns it to ash. And then the block gets put into a shot blasting machine, which is small, tiny little beads of stainless steel or steel shot, and it pretty much pelts the block with it. It removes paint, it removes the ash. It does a real good job of cleaning it. It's probably not the best way to do it, but it's a very good way, and it's a very industry accepted way to do it. For a little while there, I was taking blocks to a place in Allentown and having them dipped in acid, which does a good job also, but as far as I know, that company is now out of business. So shot blasting is what I was left with. So we baked it, we shot blasted it. We had it magnafluxed to make sure that it was good, which we were pretty sure that it was. I had checked the bores before it left and made sure that they were standard because we're planning on going to 30 over. The bores measure at 4.320. So once it was baked, blasted, and magnafluxed, the main caps were installed, a line bored, and a line honed. Also, the block, the lifter bores, we had the lifter bores bored to their proper location, and then bush fit with bronze lifter bores, sleeves rather. And what that does is when you degree your camshaft, you make all of your adjustments, your advance, your retard, you zero, however you're going to set your camshaft up. You do that all off a number 1 cylinder. most guys don't degree all 8 cylinders. That's a lot of time and a lot of effort. And usually what you'll find out is it's a problem with the block if it doesn't come up timing wise correctly for every cylinder. So when you do this, what this does is this ensures that you're going to get the correct cam timing out of every cylinder. So then you just degree your cam off of number 1, and if you're 2 degrees advanced, every other cylinder should be 2 degrees advanced, and that's that. So we had it bored and bushed. So in my opinion, if you're working with a stock engine block, that's probably one of the biggest things you can do to it as far as a power increase is concerned, or just not losing power is concerned. Probably more important than trying to blueprint place your cylinders. You know, with a block like this, that's probably one of the biggest things you could do. I wouldn't want to try and blueprint these. When it comes to small block Chevys, when you blueprint a small block Chevy, you're probably going to have to take it to at least 40 over. Sometimes they have to go to 60 to correct the casting differences and things like that. So went to the machine shop, got the lifter bores bushed, got the main caps installed, got cleaned up, and when it came back, what I started doing was I deburred the block. So these casting flash, and Chrysler is really bad for this, casting flash in these areas, there's a lot of extra casting in there and little pieces that can break off during vibration and whatnot while the engine's running, and you don't want that to happen because that's going to end up in your oil pan. Possibly, you know, if there's enough of it, I guess it could clog up your pickup, but probably not. But it's a good idea to remove that. So I did this up top. I did the outside too, just because it makes for a cleaner job, makes it look good. So another thing that I did was I filled the block up to the core plugs. So there's block filler here, and the block filler that I use, if you've ever heard of a company called Childs and Alberts, they used to make some really good epoxy based block filler, but Childs and Alberts has been out of business for a while. So this, I believe, is the same stuff. You know, it has the same instructions, it has the same claims, it looks exactly the same. I've done it before with Childs and Alberts. I fill my street engines, I like to fill them to the bottom of the core plugs. It adds a little bit of stability to the bottom of the cylinders. It helps to maybe strengthen the block up a little bit. This block in particular, if you fill it, you can still use your drain plugs. And I made up a fixture to do this. And with that fixture, we came up totally flush with the core plug here. And I also, actually, it's a little bit higher towards the back of the cylinders. So I was able to adjust my angle so I can get a little bit more filler in it. Now, some drag racing guys, they'll fill it up to the water pump holes, you know, up to this area here, and that offers a lot more stability. But for the street, something like that, it gets kind of questionable. So like I said, my street stuff, and this is going to be a street motor, probably 80% street, 20% drag. I like to only fill them up to the bottom of the core plugs, so it doesn't cause any problems. You won't have any issues with overheating. I've done plenty of blocks like this, small block Chevys, big block Chevys, etc., and everything, it works out pretty good. It doesn't hurt anything. You almost never know it's there, except that it offers a little bit extra stability as far as the engine goes. So another thing I did while I had it here, I did some work in the crankcase area, and let me flip this thing down and I'll show you. Give me 1 second. So another thing that I did was, Chryslers are really bad for casting flash as far as their molds are concerned. So I ground away that casting flash, smoothed it out, made it look pretty presentable. Did that on both sides of the block. So I also dry assembled this. So I checked my main bearing clearances just to be sure that we're good and everything's looking the way it should. The main bearings are going to get sent out to a company called Swain Tech and actually get a a dry film lubricant coating put on them. So I did dry assemble this. I had the crank in it. I checked clearance as far as the connecting rods go. They actually cleared, but they were a little bit tight. And if I had everything together, I just marked it and went in with a die grinder and just gave it a little bit more. You know, more clearance is better than really, really tight clearances. And you can see I really didn't take a whole lot of material out of this thing. But now we have clearance as far as the block or the connecting rods are concerned. This is going to be, like I said, a 505 stroker, which is very similar to a 496 Big Block Chevy stroker. So it's the same stroke length. It's a 4.250 stroke. The Big Block Chevy 496 is actually a 60 over block, which comes out to 4.310. But standard bore on this block is 4.320. So when you go 30 over, it becomes 4.350. So you end up with 505 instead of 496. And what we have for this, we have a scat crankshaft that is a 4250 stroke. It's made to work with 6.800 rods, and the rod journals are ground to 2.200, which is a Big Block Chevy size. So we have Big Block Chevy connecting rods. These are 7.1 connecting rods. They will fit the crankshaft because it has been ground for them. They sell that off the shelf. We're going to use a set of diamond pistons, and we still have to place the order for those, but diamond pistons are made to work with these rods and this block and this stroker combination. So should work pretty good. The main torque on these is 100 foot-pounds. Like I said, ARP main studs, and you got to use ARP Moly lube. I did make a notation on the oil pan rail. So ARP Moly lube works really well. I like to use lacquer thinner and brake clean to clean my parts as I go. So other small parts with this engine are sitting there. 3/4 groove main bearings, which are going to get coated because you can't buy them coated. And if you can, good luck finding them. I couldn't find them. So this block has a lot of grinding grit in it, but it's not finished with its machine work processes, so I'm not really worried about it. It's pretty much ready to go back to the machine shop. It's going to get decked to a 0 deck, meaning that when the pistons are at top dead center, they will be absolutely flush with the top of the deck. Factory deck height on this block is 10.725. We are going to deck it down to 10.705. And we are going to bore this to 30 over. We'll end up with a bore of 4.350, and it will be torque plate honed. So, and there's a set of connecting rods, or I'm sorry, not connecting rods, head bolts here that we're going to use to torque down the plate. So, and what that does is that basically pulls the cylinders into shape as if a cylinder head was bolted onto there, and then you finish hone them, and then when the actual engine is assembled, you should end up with a cylinder that is very, very close to round. So the reason it went to the machine shop for the caps and the bushings first and then came back was because when you use this block filler, if you can see it in there, when you fill the block with this filler, it tends to pinch the cylinders. So you don't want to finish them before you put the filler in. So you want to put the filler in before you bore the cylinders. But the reason I did it after the caps was because I wanted the caps on there with the proper torque to pull the block into place before I filled it. So now that it's filled, now that the bolt holes have been tapped, and by the way, I forgot to mention, when you have a block shot blasted, a lot of times the shot blast will peen over the first thread. So you either want to go through with a tap or a thread chaser to clean out all the bolt holes on the block. Otherwise, you're going to have trouble getting the bolts to go in. So I did the head bolt holes, the oil pan bolt holes, the timing cover bolt holes. Everything's been gone through, even the bell housing bolt holes, because you don't want to try and have it trying to put it together or put it in the car and a bolt doesn't want to start because there's a problem with a hole, and now you got to try and fix it. So that's one thing that's a given with shop blasting. You got to do that pretty much immediately. So like I said, it's dirty, but it's going back to the machine shop. It's going to have more chips all through it. So what they'll do is they'll deck it, they'll bore it. It should be ready to go. I'll probably have them wash it in their jet washer, and when it comes back here, I'll probably wash it again and clean it up, make sure that we're all good, and hopefully we can move on to assembly in the next video. Thanks for watching, and stay tuned. There'll be another one coming up.